This is a video for Edexcel Further Pure 1. Inequalities section 1.3, solving algebraic inequalities of the form f of x is less than g of x. Well, if algebraic fractions are not involved, then we can easily rearrange the inequality to give us one of the form h of x is greater than 0. So let's look at this particular example. What we have to do is to take the right hand side by subtracting so that we get greater than 0. And therefore we can write that as x minus 2, x minus 1, minus x minus 6, 1 minus x is greater than 0. Now, one mistake to be aware of here is sometimes we see students who multiply out these brackets and then try and factorize from the resulting cubic equation. However, here we've got common factors. X minus 1 and 1 minus x are negative of each other, so we can take that out as a factor outside a large bracket. So if I take out the factor x minus 1, then inside we're left with x and then x minus 2, and then instead of minus we're going to have plus x minus 6, and that will be greater than 0. So then you need to multiply out the square bracket x minus 1, and inside the square bracket we'll have x squared minus 2x from the first two factors. Then we've got plus x, so that in total is minus x, and of course then we've got minus 6. That will be greater than 0. This factorizes, so we end up with x minus 1, and this factorizes to be x minus 3 and x plus 2. That will be greater than 0. So we've turned our initial inequality where we've got functions on both sides of the inequality into one where we've got greater than 0. And that can then be solved in the same way as we've seen in previous videos. Here's that written out again. Notice here I've just simply put these factors in order of when they change from positive to negative. So our critical values are at x equal to negative 2, x equal to 1, and x equal to 3. So this is where things are going to change. And what you might want to do is to pause the video here and see if you can follow through and get a solution. Well, we know what we have to do to get the solution. We simply need to look at whether each of the factors is positive or negative. So it starts off with all of them being negative, and hence the function itself, h, is negative. I'll now just skip to the finished solution. And here we are, and I'm sure you got the same answer, at least I hope you did. Now we want to solve this equation which says greater than 0. So we want the values where the function itself is positive, so that we have the region between 2 and 1 and greater than 3. So our solution will be x such that negative 2 is less than x is less than 1, union x such that x is greater than 3. Remember again, had it been less than or equal to 0 or greater than or equal to 0, then you'd have to be very careful about the critical values and whether they're included in the solution or not. For a simple polynomial such as this one, then a graph might be useful. So here we see the graph, the critical values here marked on. We've got negative 2, 1, and 3. Remember, we want the values for which the graph is above the axis. So it starts at negative 2, going up to 1, not including those values, and from 3 upwards again, not including the 3. If we have algebraic fractions to deal with, then one approach is to combine them into a single fraction. Remember, you can't simply multiply here through by x minus 1, because sometimes that is positive and sometimes it is negative. So we need to combine these into a single fraction by first of all rearranging and then multiplying out. So let's look at that on the next slide. Here we have it written out. Remember, of course, that we've got this x is not equal to 1 again. That's because the denominator here will be equal to 0 and we have an undefined value. What we need to do is to write it as x plus 1 and then minus of the fraction 2x plus 7 over x minus 1, and that will be less than or equal to 0. We can now combine the left-hand side as a single fraction with a common denominator of x minus 1. So we'll have x plus 1 multiplied by x minus 1 and then minus 2x plus 7, and that will be less than or equal to 0. Now x plus 1 and x minus 1, well, that's x squared minus 1, of course, difference of 2 squares. So we get x squared minus 1, so in total we've got x squared minus 2x, and then minus 1 minus 7 minus 8 on the top line, over x minus 1, and that is less than or equal to 0. And finally, the top line, the quadratic there, will factorize, and it will be equal to x minus 4, x plus 2, and then divided by x minus 1, and that will be less than or equal to 0. To solve this, we look at the critical values, which are x equal to 4, x equal to negative 2, and x equal to 1. Put those in a table to show the regions where the graph is going to be positive or negative. So here we have that table. So our values of x equal to 2, x equal to 1, and x equal to 4, sorry, I beg your pardon, x equal to negative 2 is the first one, 1 and 4, give the intersection between those regions. Remember though that we have x is not equal to 1, so this value here gives us an undefined value, and that's very important when it comes to looking at the solution. Again, what I'd like you to do now is pause and just work through that solution yourself to see if you can come up with the full solution to this problem. So here's the completed table, and we want to look at x is less than or equal to 0, and so we want the negative parts of the table for h, and we must be very careful again about these critical values. So looking at our table, we know that negative 2 will be included in the solution, so will 4, but the value of 1 is not. So the solution will be the set of values x such that x is less than or equal to negative 2, union with the set of values x such that 1 is strictly less than x is less than or equal to 4. So just going through that method again, we started off with f of x on one side of the inequality and g of x on the other. So to combine them, we've subtracted the right hand side and combined them into a single fraction factorized. Once we've done that, it's relatively straightforward, but again, just remembering that this idea of less than or equal to, or indeed greater than or equal to, causes us to think very carefully about the critical values themselves and whether they are included or not included in a solution. In the questions, you will be told the undefined values, so x is not equal to 1. Make sure that your solution does not include 1 in its final written form. Well, that's the end of this video, and in the final one of the series we'll be looking at some alternative methods for solving algebraic inequalities.